Good afternoon. My name is Reece. I am technologist at Award Solutions, and I'll be the host of this complimentary webinar. Joining me is Jennifer Yen, director at Award Solutions. She will also be contributing a lot of key information to our discussion on visualization. What we're going to talk about today is going to include topics of what is visualization, a little bit on some of the process of visualization, and we're going to conclude our time together today looking at an example. Solutions, we are a proven technology training leader. As you can see on the right-hand side of this graphic, there are many different areas that we have classes on. Start off by giving a thank you for spending time with us today. And I'd like to thank you by giving you a coupon code to take a upcoming data visualization workshop using Power BI. Starts on November 18th. At the end of this webinar, or after the webinar, you will receive an email which will have a link to a recording of this webinar, as well as to a PDF of the material. Included in that link will be the webinar coupon code as well. If you'd like to contact me for some more information about that, feel free to reach out to me on LinkedIn. Today is as follows. An introduction to visualization. We're going to look at some of the principles of visualization. And then we're going to look at an example from our data visualization using Power BI course. An introduction to visualization. But before I get started, you should have a chat window that is available to you, as well as a Q&A window. If you do have questions, feel free to put them into the chat or the Q&A, whichever you're more comfortable with. I will both receive those. We will respond accordingly. And at any point during the presentation, if you do have questions, please do ask, and we'll definitely take all of the questions and try to deal with them as they come about. Let's go ahead and get started. Why use a visualization tool? I see anything like this, the first thing that comes to my mind is a Gartner report that I saw a few years ago. It talks about how we are becoming more and more of a data-driven industry. As a matter of fact, it's a term that's being used quite often called a data-driven business. And really all the term means is that I'm using more and more data to make decisions about how I want to move forward in my business. That data that I might use, well, it's going to depend on your business, obviously. Now, there's so much data that we have. If we have all of this data available to us, we can't just sit looking at it using Excel spreadsheets. We need something that's going to help us understand what the data really means, and that's where visualizations come in. So some of the reasons that we want to use a data visualization tool would be things like data volume. We have a large amount of data, a lot of data interactions. Our brain just doesn't think in rows and columns. I mean, think about where you've seen data in tables versus you've seen a chart. Which has been more compelling to you? Which has helped you understand what's going on? Another reason we might want to use a data visualization tool is there are multiple data sources. In the telecom industry, which is where Jennifer and I have spent our careers, there are tons of different data sources that are available. Those could be anything from equipment that's doing KPIs or some type of counter information. It can be from billing records. It can be from subscriber databases. Ton of different data sources available. And going a step further, those data sources are going to include or are including things like social media posts or even opinion polls. Be able to take this visualization tool and come up with a custom KPI, a custom key performance indicator. That I can take all of this data and construct something that's meaningful and valuable for me. the decisions that I'm trying to make. And the decisions I'm trying to make may be different than the decisions that you're trying to make. So we may have the same data, at those in different ways. You can start to play what-if analysis. You can use this data to find trouble spots. The things that Jennifer's most excited about with respect to visualization tools is an interactive dashboard. And Jennifer is the person that does the scheduling at Award Solutions, and she's going to come and give you a couple of personal stories on that, of how she's using visualization tools here in a few minutes. But for her, if she can put the key elements in some type of a dashboard, it helps her make the decisions that she needs to make. On top of that, she can create a dashboard that can help some of the other leaders within Award Solutions see the challenges that we have. And that's also a win for her. And then the last thing we have is some form of advanced analytics. How can I take all of this data and process it in a way that's useful for me? That's why I use a visualization tool. So if we go to Gartner and we look at their Magic Quadrant report, and this comes from earlier this year, 2019, we can see all of the different visualization tools that they looked at. And we can see in the upper right-hand corner of this, here it is, we can see Tableau and Microsoft. And for Microsoft, what we're really looking at is Power BI. It stands for intelligence. We're going to show some examples using Power BI towards the tail end of our time together today. But Tableau is another very popular tool that is being used. And I have some examples, and I'll talk a little bit about Tableau as part of our presentation today. Not the only two games in town. There are many other examples. This upper right-hand quadrant of the Magic Quadrant is really the desired place to be. What this says is that you're a leader and a visionary when it comes to these tools. You're not just a follower or up and coming. So this is a very desired place. So these are two of the most popular tools that are being used. So we've talked a little bit about data visualization. What is it really? What is data visualization? And it's more than just drawing a few graphs. That's kind of the nucleus. That's kind of the starting point for this conversation. The first thing we need to think about it is trying to do some type of a graphical representation of data in a way that's meaningful based off of that data. So that could be some type of a traditional chart, a line chart, a bar chart, or it could be some other type of graphical representation. We're going to see a couple of examples here in a second that I really like. We're using maps to help us understand something about what's going on with the population of people in that area. We're in the middle of the political season here in the United States. It's going to go on for another 14 months. We're going to see a lot of maps that are going to be used with respect to how are people voting, what are the polls like. And so every time you see a map like that, I want you to think of that's a visualization. That's somebody taking some large amount of data, drawing a picture in a way to try to convey a specific meaning. What is that specific meaning we're trying to convey? For the sake of what we're doing within the telecom industry, it's some type of business intelligence, some type of an analytics. So when we use this term business intelligence, what we really mean is we are taking some type of data and analyzing it in some way so that we can take some action on it. It's not just looking at data for the sake of data. It's not looking at saying, okay, here in the Dallas-Fort Worth area, the temperature is 78 degrees today. Okay, great. What is that action that you need to be able to take? Looking at business intelligence comes in. So based off of how we're looking at the data, analyzing the data, that'll lead to some action that we need to take. Another thing about visualization is we want to take looking at this data, we want to turn this looking at this data as an easy and repeatable. So if I go back not too far in time, the way that I used to do the job that Jennifer is doing now is we have an internal database that does all of our scheduling of classes. And I would export the data, I would put that into a spreadsheet, manually copy and paste columns of that spreadsheet. I would create a pivot table, and then I would analyze the results. And I would do this every day. It would take me 15 minutes to half an hour to do that before I actually did my job. What I looked at as automation, what I looked at as making this easy and repeatable, is I hired an intern to do that for me. Half an hour, in an hour. It was still time that I got back. We want to take this, gathering this data, processing this data, and make it something to where I can update this data and make this process very, very easy to repeat. Some examples. So here are 3 examples that comes from the US Census. On the left is just a very, very simplistic bar chart. And if you go to census.gov, you can find the data that produced all these, and you could produce these charts yourself if you so want. So in the United States, looking at what percentage of people became a first-time dad at different ages. And so this is kind of interesting. All of my kids are college age or older, so that train has sailed for me. Jennifer and I have a colleague who is, we'll just say he's in the 3.3% at the bottom. Just became a father. He's in the 3.3%. But you can see it's a very easy way of showing those numbers versus just a table. The second one is looking at the number of people, percentage of people who voted at certain ages over time. So you can see from 18 to 29-year-olds going back to 1980 in comparison to older ages 65 and older, and so on. And then lastly, this is my favorite of the lot, is a comparison between 2005, 2015 of the percentage of people who have children over the age of 18 living at home. What percentage of homes have that? What we're now starting to refer to, maybe these are failures to launch or boomerangs, right? So those are the 2 terms that you hear. I have one of each of those living at my house right now in this category. But again, you can see how this is much more compelling to look at a chart like this than it would be to look at just a table of numbers. In Texas, it was below 20% in 2005, and now it's above 40% in 2015. Examples of data visualization. So let's look at this from a process perspective. The first thing that we need to do is we need to actually gather that data. We need to extract that data from its sources. And there's 2 main ways in which we're getting that data. Typically, we're either getting that data from specific equipment, some type of a data lake concept. So when I talk about specific equipment, what I mean is, especially within the telecom industry, in things like I need to log on to my radio network equipment. and I need to pull down that data, or I need to log on to core network equipment and pull down that data, or I need to go to this database or that database and pull in that data. So that's what I'm really talking about when I talk about I'm getting the data specifically from a piece of equipment. So if I've got 100 pieces of equipment, I may need to make 100 queries to get that data and then kind of pull everything together. The other example is where, and we see this at a lot of larger companies today, is where they're starting to form what's referred to as data lakes. And what a data lake is a term where I'm pulling data, and that's all my job is to pull data and store it in this lake so that other people don't have to pull the data from all the different equipment. They can get the data out of the lake. We just at Award Solutions over the last year moved from kind of that first approach, was having to log on to all of the individual systems to get the data, now more of a data lake mentality. So now if I have something I need to do, if I've got a visualization that I need to do, an analysis that I need to do, all I need to do is to access that data lake. All the data is there. And then I just need to process it in the way that I need to. So first, we need to extract the data from the sources. We need to get that data into our system. The second thing we need to do is we need to clean the data. Data is notoriously, for various reasons. It could be dirty because of a problem in transferring the data. It could be dirty because of a hiccup on a piece of equipment. It could be dirty for many different reasons. So I may need to clean the data. What do I mean by cleaning the data? Really, I mean two key things when I talk about cleaning data. One is removing bad data. I have an entry that has no values in it, or infinite values, or anything that is not usable. I need to somehow remove that bad data. Now, depending on the nature of the problem you're trying to solve, you may just delete that row. That's what I do most of the time. Because if the data is bad, it doesn't add any value to me. Also, what I might need to do is I might need to, and I'll just say, fix the data. So for example, if what I was trying to do was to do some type of analysis of equipment sold over the last 10 years, and some data is bad on a few days, I probably don't want to delete that, because that's going to make it seem like that quarter's sales were lower than they really were. So what I might do is I might replace that with an average of the quarter, or an average of the week, or I might have some other type of typical number that I use so that I'm not artificially lowering. So that's going to be dependent on the nature of the business and the problem that you're trying to solve. So first, we're going to get the data. The second thing we're going to do is we're going to clean the data. The third thing we're going to do is we're going to do transformation and business rules. When we talk about business rules and transformation for that matter, we're really getting into something that's got more of a domain expertise. We're going to make decisions based off of specific problems now. Up to this point, I can write pretty generic code to do the extracting of the data and the cleaning of the data. I don't really need to be a domain expertise, a domain expert. But once I get into the transformation and the business rules, some examples of business rules may be simple things of just what formulas do I use for the sake of the problem I'm trying to solve. So I was doing some very simple averages, playing with some things yesterday, but that the formula was very dependent on the type of problem in the data that I was trying to do. Solutions, the way that we store information is we typically store things on a start day of a class Now I know, oh, okay, so if I want to know what day the class ends for some reason, I need to take the start day and modify that by the duration of the course. Make sure that everything works out okay. So those are some simple examples of transformation in business rules. Load the data into type of visualization, or give me a good example of loading targets, Jennifer.
And this is what the domain are. Okay, if you want to look at, you're going to have to make sure that
We'll talk about a dimension, but the simple answer of a dimension. So visualization does have some specific jargon that they use. And so when you hear something like a dimension, think of that as kind of like if I take a very simplistic XY scatter, the values I put on the x-axis, the values I put on the y-axis, those are dimensions.
once you define those, then once you understand what you're trying to, that's how you define your visual. All available to you. And what you want to load, you load it.
Let's take the same picture. If there's any questions, please jump into the chat, jump in the Q&A. Let us know if there's anything that you want to talk about. But let's take this same picture and let's take it one step. This is an example of a number of tools we might use for the sake of doing each of these individual steps. So we need to get the data from different sources. Be using some type of relational database management system. Use the web itself and do some type of an API pull, or you might just have this as some type of a file, maybe an Excel file or a PDF. I'm going to put a CSV because I think that needs to be even though a CSV is kind of a subset of the text files, I see a lot of data coming in as CSV files. I've taken all the data and I've gathered it into some type of source data. Now, maybe I'm connecting to the source directly within the tool like Power BI, or maybe I'm just storing it as a file locally, like in the case of a CSV. So for example, if you wanted to recreate charts like this, you could do it. And as a matter of fact, I highly recommend doing that to try to practice. All you have to do is download the census data, which is free. You can use a tool to actually draw these types of visualization. There's a lot of different data that you can use for that. We'll then do some type of data cleaning. Maybe we're going to use some tools like Address Doctor or our First Logic. Here toward solutions, one of the things, and this is a lot of our clients, what they do is they use Python. What I can do is I can use Python to, one, pull the data from all the locations that you need to pull the data from, and then two, do a first pass set of cleaning that data. So that when I go to actually put that data into my visualization tools, I can focus on things like the transformations, the targets, and the reporting. That's what we do. We find that a very easy way of doing things. transformation. Now we could do that transformation within Python itself here, or we might use things like Microsoft's query editor, or we might use Tableau's data prep tool called Prep, other tools that you see here. Target, and we do the actual reporting itself. We're going to show you an example using Power BI desktop. The Tableau desktop will do things in a similar way, as well as some of these other tools that you bit about Tableau. We're not going to talk about Tableau too much, but Tableau does have a suite of products. Talked a little bit about Tableau Prep. What it's doing is helping us prepare the data and doing extract, transform, and load. That's what ETL stands for. Desktop is something that I can download. It's a paid product. I download it onto my computer. It lets me do all of these things. There's a Tableau Reader, Tableau Viewer. Allows me to see visualizations that other people have done. So think about this in the form of inside of your company. What you might do is you might do all the work to create a visualization, and then you can publish that visualization. When you publish it, other people will then be able to look at it and use it. And so this is not the same as just exporting something to a PDF, by the way. If I export it to a PDF, it's kind of like printing it to a page, and all you get to do is look at that printed page. What I'm talking about is something that still lets you have some of the interactive qualities of the visualization without the ability to create your own things, if that makes sense. That's what we're talking about on these two right-hand products. Tableau Server is a product that lets you have basically Tableau running internally so that you can do all the sharing. There's a Tableau Online and a Tableau Public. Both of those are cloud-based products so that I can share things. And then lastly, there's a mobile version. There are similar things for Power BI, but just kind of an example with. Before we talk a little bit about principles of visualization, I wanted to turn the microphone over to Jennifer for a second and let her talk a little bit about how she's kind of changed the nature of the way that her job runs. So here at Award Solutions, we've been around for 22 years, and basically a number of people have done this job of scheduling, managing the schedule. And it is one of the tougher jobs that we have here. I've done it a couple times. And Jennifer's had the privilege of taking over that role. And so, Jennifer, tell us a little bit about how you've modified kind of the processes that you've done for that role. I'll let you have more of the camera.
Thank you very much, Chris, for the introduction. Yeah, so one of the things, the challenges that I faced when entering this is the complexity to be able to see all the information that I need to order to be able to and looking at before classes, after classes, in our if you, I've got several different sources of information. So as you saw in some previous slides, where you can actually where you pull information. So the first step is to pull information. Actually, let me. So in my case, there are several different areas, and some of it is also financial information where my source material or source data is coming from. So I'll just call those. Over here. A purple pen.
I do not have a purple pen as my default.
I have the source one. All my sources are different systems within our organization. Some of them are cloud-based systems, some of them are internal systems, and some of them are just simple that we maintain by other departments. And so if you look at all of the different sources, Okay, and all the different sources are going to be coming in different forms. Some of them are SQL servers. Some of them are just plain Excel files. Some of them are other, like I said, the cloud-based systems. So I'll just kind of draw a couple of boxes here. So let's say I have these 4 systems. And so how do I visualize the data in a way where ultimately what I'm trying to do is make quick decisions? In order to make these quick decisions on scheduling, or it could be business decisions, it could be product-based decisions, I need to be able to see all of these very quickly and really up-to-date information. So how do I do that? Because it's short of logging into 4 of these systems, pulling them out, exporting information into an Excel, pulling them together in Power Pivot, pivot tables, whatever. That's a very time-consuming process every time I have to update this information. So what we've done is I work together with our automation team internally, who have been working together to somehow pull all of this information together, the data cleaning process, if you will, that second step in our iterative process steps. To how clean. We have a group of these Python that where we consolidate sources. So one could just be a very simple export into an Excel file. So we'll call that system 1. This exports an Excel file. System 2 is a cloud-based solution that has an API that allows us access to that particular system. And we have another API over here for system 3. Then system 4 is a database that allows us to execute SQL commands to extract the data from that system. So we'll take all those as inputs, and our group of Python modules that really goes through and cleans this data. Cleaning process. So that way it's able to go through and kind of massage all of this information into a format where I have a collection of files, which I can now pull into Power BI. So out of that Power BI, in the back end, we're using Power Query to what we call transform or shape the data. That third or fourth.
Third.
Transform the data, transformation. This is also called data shaping, if you've heard that in the past. So actually, what a lot of the time actually is spent on this entire process is, okay, how do we clean our data so that it all kind of ends up in the same form where we can compare and everything together, and then this shaping the data or transforming the data. So I'll give you an example. Let's say I have some data in Python that comes out, and the Excel shows me a column of data that has numbers 1, 2, 3, 4. And then sometimes out of system 3, I end up with something called not available. Well, this might be a column I want to do averages on. And so when I pull that into Power Query, it doesn't know how to do the average because it doesn't know what this NA means. It's not a number. And because there's that NA there, it's tagged this a text column instead of a numerical column, in which case I can't do an average on a text column. So what happens is first you have to clean it to get rid of this NA, in which case I have to decide to leave it blank, put a 0 in there, whatever value I want. That's where that domain knowledge comes into the picture. And then second, I'm going to have to transform it and change this into a number, a whole number or some kind of number. So that way, those are two specific, very simplistic examples of cleaning the data and then transforming the data. Once we have that, and my data is nice and clean and transformed, then I go into my visualizations. Actually, before I do my visualizations, I have to create my data model, in which case, out of this Excel, I have all these different tables, and I have to make relationships between these tables to understand, okay, this is how they all relate to each other through an index, or defining uh, dimensioning parameters. So I know how to relate these two together. And once I have my data model, then I can create my nice visualizations. So visualizations, really kind of the ultimate final the whipped cream, if you will, on my ice cream sundae. But that's really the most critical part as far as making the visualization easy to read for your readers, because otherwise it will not be consumed for your if your users aren't going to use them, basically, if it doesn't look good and it's not easy to understand. Really, if you look at the big picture, the cleaning is very, very obviously very important, but takes a good chunk of the time, maybe 50% of the time, I would say. Transforming is also going to be important, and this is kind of a repeat process. You transform it. Does it give you what you want? Maybe not. You have to go through another iteration of transformation. Fortunately, most of these things are really a one-time operation. Once you figure this out, it's not really something you have to spend as much time on after the first time you've done it, because once you've built it, then you can just use it over and over again. Same thing with the data model. Once you've created that once, you can create it, and then that data model, even before you get to the visualizations, can be shared with other groups in your team, other teams, whatever. And so that once you have that data model, they can create their own visualizations, or you can also share the visualizations for end users just to read from. That's kind of like the high level use case that I've been working on. And it's kind of a continuous process, because once you create a couple of these and you kind of understand how powerful they are, you start having ideas of what else you can visualize, how else can it help with your decision making in your everyday functions, in your business decisions, all the way down to we have several financial charts that really show us real time about how we're performing, what decisions we need to make regarding financial and other KPIs.
Plus, if you're like Jennifer, you can just get addicted to making visualizations. It's a different story. Okay, so hopefully that was useful. That was one of the main reasons why I wanted Jennifer to say something, is because I knew she's got more of that firsthand experience. She's actually transformed the nature of this job based off of this. And it's really kind of exciting to see, especially having been a predecessor to her and having done it in an older way, seeing some of the changes that she's brought into this. And really, the advancement of these visualization technologies has helped greatly being able to do this. Some of it really is nothing more than there's a tool available now that we now understand how to use. And that's how we're moving forward with this. Okay. So next thing we want to talk about is principles of visualization. So give me a few minutes, and I'm going to walk through some of the principles of visualization, and then I'm going to come back and we're going to actually do a demonstration here in about 10 minutes or so. So first thing we need to understand, and Jennifer started this conversation very well, is there are different types of data that you may need to have. There are certain things that are nominal data. Nominal data is non-numeric data, and you cannot do mathematical calculations on this data. Names of people, gender, department names. I've been looking at a lot of the stuff coming from census or other kind of government-based data sources. And so states, county names. So they have those names are very meaningful. They do mean something, but they're not something you can do any arithmetic on, right? You can't take 4 plus Oklahoma. So that's nominal. Nor does there have a ranking necessarily, right? So Oklahoma is better than Texas. I can make a strong argument that the opposite is true. I've grown up in Oklahoma, but you see what I mean. Now, I might have something that says population of Oklahoma is higher than the population or lower than the population of Texas. Okay, so it's really the population is the number, but this nominal label is the state. Another one is an ordinal. Now, the difference between nominal and ordinal does have some form of rank associated with it. Think about this. If I were to rate students in a class average high, which is the best rank? That's high. If I were looking at this from the point of view of some type of trying to think of another good example, but it's any type of, or even maybe the words first, second. So those have a rank to them. Now, I may transform them into numbers 1, 2, 3, or I may do something else to keep them in some form of an order. But the key point is when you're dealing with ordinal data, there is some form of a ranking or some sort of a sorting that can be done. Ratio, which is really everything else. It's really what we think of as just this numeric data. It can be sorted. It can be ordered. You can do math on it. You can have this as integers, or you can have them as real numbers. Some examples: sales, height, weight, elevation, number of employees, number of people who voted, number of people that are between ages of 18 and 25. So anytime there's a number, anytime that I can do math, that's going to be a ratio. Take that one step further. So we've already talked a little bit about this. And we have something called dimensions and measures. A dimension is something that's categorical in nature. It's not used for calculations, but it is something that we could do some type of a mapping based off of. So for example, if I wanted to do, and let me do measures, and then I'll come back and give an example. Measures are really math. It's some math based off of data. I've done some calculation to do something, right? So this is also referred to as a fact or a dependent variable. I can do aggregations based off of criteria. I can do slices based off criteria. They can be summed, averaged, min-max, all that kind of stuff. So I've got a couple of examples, but let's take the 2016 presidential. So I had, for each state, I have a number of votes, the Democrat or the Republican. So that would be an example of something I might be able to visualize. So a state would be a dimension, and then the vote, the number of votes cast, would be the measure. Or I might say not votes, I might say percentage Democrat versus Republican. Or I might say max, which had the most number of votes, the Democrat, the Republican. And this measure can be quite complex. It's not just basic arithmetic. It can even be things like if-thens. So depending on what you're trying to look at, I can create a measure based off of that. So for example, I was playing with this a little bit yesterday. And so I could say, if the votes for the Democrat are greater than the votes for The Republican, output Democrat, else output Republican. So now I've created this measure that gives me this output here. And then I could plot that in some way. Right? Maybe say if Democrat, make a state color red or blue. If it's Republican, make it red, for example. Right? So a simple example, and I'm not trying to be political, but I like using politics in this example because it's so easy to visualize and we've seen it so often. I could do the exact same type of discussion with rainfall on a per state basis or average temperature in the month of September. The left is the state, the right is some simple math based off numbers. Okay, cool. So if we think about the numbers themselves, there's two different types of numbers that we're going to have. We're going to have discrete and continuous. When we talk about discrete, what we're talking about is a fixed subset of. So in other words, how many eggs do you have in the carton? They don't sell 2.4 eggs. You can't have a 0.4 egg. It's typically just represented as some form of an integer. Fixed number of them, right? You go to the store, you typically buy 6 eggs, 15 eggs. So that would be an example of discrete. Number of employees that you have, a discrete number. You're not going to have 2.4 employees, right? Because we've had some pregnant women in the company. We don't count that. Continuous is something that is, you can have any number in there at all, right? So 2.3 is a legitimate thing. 4.7 is a legitimate thing. So it's typically represented as a real number. In the telecom industry, a lot of counters fixed size that they have, a fixed number of variables. But typically things like anything related to money is continuous. In all of our data, we've done the appropriate math, and now we're trying to make some type of inference. We want to draw a conclusion based off of something that's coming up in here. There is a granularity that we can have. So the higher number of dimensions that we want, that's going to allow us to have a higher amount of granularity. So if I were to make a statement like, in 2016, the state of Texas voted for the Republican. That's a true statement. But it's not giving you all of the detail that you might have. Did every county in Texas go for the Republican? What percentage of the vote? Was it 51% of Texas or was it 90% of Texas? That's where you can have more detail and go to a higher level of granularity. And then the more marks, what this is really talking about is think about this as like the little tick marks on a chart. How much detail, how much granularity can you get into? I'm going to kind of skip through the next couple of slides because what I want to do in the few minutes that we have left is I want to use an example in Power BI to kind of prove some of these points. So let me go ahead and open up my Power BI. To start here, I'm going to start with this, and this is some data that we downloaded off of the internet, and this is again a very common set of data that you'll use that focuses on, in this case, pollution data. And so you can see I've got a column that has CO2 emissions. I have a column for country codes, county name, the currency unit of that particular county, country. I keep saying county, I'm sorry, country. What is the income group of that particular country? Methane emissions, nitrous oxide emissions, population, region, and the year this particular study was done. So that'd be an example of the data itself. If I wanted to add more data, if I wanted to say, like, take the difference between the methane emissions and the CO2 emissions, I could do that as another column. I could add that to this data. So this is an example of that data just being drawn as 3 different bar charts. CO2, nitrous oxide, methane emissions based off of regions. And then I've got a thing up here at the top that says year. This is referred to as a slicer. And so this particular data, the latest year we have is 2012. But let's just go back in time. Let's go to 1976. Well, it didn't stick. There it is, 76. So now what it's done is it's updated all of this data based off of the 1976 details. So Europe and Asia had the highest amount of NO2 emissions. So I'm going to click on that, and you'll see how it highlights the equivalent region in the other charts. I can right-click on this, and I can show data. And now what it's doing is it's going and saying, what was the details of the individual charts in here? Or another year, right? No big deal. We can then look at what is the average over time. I can look at all. So this is saying what the total is over the same data in other formats. It's not that big of a deal. But I hope you can start to see a little bit about how I could use this data to make some type of a decision. Here for a second. Back to my things I could do at this point is I could publish this visualization itself, and I could give you this data. Now, you can't modify this, but you could still look at some of the details. Or I could let you have this visualization in an editable form, and then you could go and you could modify this as you see fit. You could come in here and you could say, well, what I want to do is I want to add another column based off of whatever, and then go and redraw this visualization. I can do filters based off of this. So for example, I could take this filter and I could say, well, I want to make it to where I'm not allowed to look at anything prior to 1980. That data, for whatever reason, I don't want to include that. Now, when I come up here to my slicer, you'll see it doesn't go before 1980. I can add additional visualizations using this tab here, or I can have the access to the actual data. So if I'm wanting to create my own visualization, add a new one real quick. I'm going to say, let's just do this. I'm going to make the year. The value, I'm going to make the CO2 emission. I've got that. Now I've created a time series, and it took me 4 seconds If I want to include additional data, I can come in here. Two lines. I can draw so just some examples of what might be able to do. Okay, so that was what I wanted to show you with respect to this example. Questions, comments, thoughts before we wrap things up for today? Well, as a final reminder, I would like to just remind you that we are doing a 3-day, it'll be spread across 5 half days, a data visualization workshop using Power BI coming up on November 18th. Coupon code webinar. Reach out to me in LinkedIn if you have any questions after this, and you will be receiving an email, links to the material, and a recording of today's session. I want to thank you guys so much, and until next time, I'm Chris Reece. That was Jennifer Yen. See you next month where we'll talk about AI.